Alrighty, hello and welcome. We got Chapter 7 in review. As always, has been the case with the last few, feel free to use this in whatever capacity you like. If you want to just watch, if you want to try and work ahead, you guys have the options to pause this, rewind as much as you want. So use it to the best you can. So, Chapter 7, test topics. Here's what you got. You need to simplify radicals and rational exponents. That was section 7.2, the stuff we did very early on. That's a big part of your test. Okay, there were a lot of properties that we used, so make sure that you are comfortable with those. We're going to be solving equations. We're going to be finding inverses. We're going to be doing operations on power functions. A big one with that is composition. That was the new one. You're also going to be asked to graph square root and cube root functions. So, this is a little lengthy, so let's get rolling right away. First slide here, we're just going to simplify. Okay, so I'm asking you here, I've got the cube root of negative 27 squared. I can break this down. The cube root of negative 27 is negative 3 squared. So that one's just 9. Okay, jumping down to 81 to the 3/4. If we rewrote this in radical notation, that would be the 4th root of 81 cubed. Now we want to be smart about this since you don't have a calculator. I definitely don't want to take 81 cubed and then take the 4th root. Remember, the order doesn't matter, so what I want to do is try and make this smaller and then cube it. So the 4th root of 81 is 3. To the 3rd power is going to give me 27. Okay, moving over to 16 to the negative 1/4. Remember that negative exponents are just moving me up and down on my fraction. So this is going to be 16 to the positive 1/4. Big mistake I'm going to see here is you guys are going to take it to the 4th power. This does not reciprocate. It just moves me down and makes the exponent positive. So this is going to be 1 over the 4th root of 16, which is equal to 1 over 2. Okay, so these are just basic ones that you can actually get a number answer or a numeric answer on. Okay, so that's the basic stuff. We don't want to go solve. Let's come back to that actually. Yeah, we'll solve. Okay, solving. These are the ones that we did right away in section 2, where I'm just asked to get x by itself. A reminder that sometimes we have to check for extraneous solutions. That only is the case when you are taking something to like the 2nd power or the 4th power or the 6th power. I don't have to worry about it if I'm going to be in this one taking 4th root, square root, 5th root. If you can't remember that, it's always good to go back and check your answers. So, here I've got 3x to the 4th. I'm going to move the 2 over. That is going to give me 3. I get x to the 4th is equal to 1 after I divide by 3. I take the 4th root of each side. Big thing here, since I'm taking the 4th root, just like with the square root, I'm going to say x is equal to plus or minus 1. Moving over to 3 minus x squared equals 1, we're going to move the 3 over, so I've got negative x squared is going to be equal to negative 2. Let's divide both sides by negative 1, so x squared is equal to 2. This is going to give me x is equal to, again I'm square rooting, since this is an even index, I have to put plus or minus 2 into my answer. Okay, so x equals plus or minus 2 right there. Coming over here to x plus 3 to the 5th equals 32. I don't have anything to move right away, so I can just take 5th root right off the bat. Left hand side simplifies to x plus 3. I do not get a plus or minus here because my index is odd. So the 5th root of 32 is 2. Subtract 3 and I'm going to get x is equal to negative 1. Okay, so still following our order of operations. The only new thing here is that we're taking stuff like 4th roots and 5th roots. After we did stuff like this, we got into graphing. So we graphed 2 functions. We graphed square roots and cube roots. And it asks us to do the domain and range as well. So just to switch this up a little bit, let's make this a plus 1. And we will do... Yeah, we'll just do that. Okay, so x minus square root of x minus 6 plus 1. I have a center being shifted to the right 6. So 1, 2, 3, 4, 5, 6. And up 1. This is my new starting point. And then I make my 3-column chart. So I'm going to go x, square root of x, and then I would go a, which in this one it's just a 1, times the square root of x. So technically I don't need that third column. On the test you're going to see ones where you do. So let's do this here. We will go with a 1 and a 4 because we want to plug in numbers that I can easily square root. Square root of 1 is 1, square root of 4 is 4, not 4, sorry, square root of 4 is 2, and then I'm going to multiply by 1. So 1 times 1 is 1, 1 times 2 is 2. This one's pretty basic. I now have my directions from my new starting point to go over 1, up 1, over 4, and up 2. Giving me a graph that looks something like this. Okay. Remember, I'm not going to have anything to the left on a square root because if I plugged something, for example, let's say we plugged 0 in. If you plug 0 in, that's going to give you the square root of -6 plus 1. When we graph real numbers, we can't do that. So, I mean, that is a domain restriction. I can't pick anything to the left. Okay, so for my domain here, I'm going to say, well, x has to be greater than or equal to 6. That's coming either from my graph or knowing that you take whatever's on the inside, set it greater than or equal to 0, and solve for x. Okay? The range is going to be everything above 1, so I would say y is greater than or equal to 1. Alrighty, over here now I have got a cube root. So I've got the cube root of x plus 3. Notice that there's nothing on the inside. This is really like cube root of x plus 0, and then on the outside plus 3. So I'm not shifting left or right, I'm just going up 3 with my starting point. So, same idea, let's make our 3-column chart here. So I'm going to go x, cube root of x, a times the cube root of x. Here again, this is just a 1, so 1 times the cube root of x. Let's pick nice numbers such as 1, because cube root of 1 is 1, cube root of 8 is 2. If I multiply by 1, I get a 1 and a 2. So those are done. I'm going over 1, up 1, over 8. 1, 2, 3, 4, 5, 6, 7, 8, up 2. And this is part of my graph. Now remember, this is a cube root, so now I don't have a domain restriction. I can plug negative numbers in here, because if I plug -1 and -8 in, cube root of -1 is -1, cube root of -8 is -2. If I multiply by 1 and 2, that's going to give me -1, -2. So I'm going to go left 1, down 1, and left 8, down 2 from my starting point. So left 8, down 2, and I get a graph that looks something like this. Domain here, it's all real numbers. Okay, we don't worry about this because I can cube root negative numbers. My range, similarly, is going to be y is all real numbers. Okay, so that's graphing. Remember, just whatever your a value is, plug it in here, and then these are directions. Coming up with a graph, or given a graph, come up with the equation, the domain and range. So let's just do the domain and range here. So I'm going from -5 to 5. This starting point is left 3. So I'm saying x has to be greater than or equal to 3. My range is y has to be greater than or equal to, it looks like -3. My graph never goes below -3. So my equation, if you remember what we talked about, finding this first point here, when I go over 1 and up 3, that's telling me about my stretch. So for the equation, let's move down a little bit. For the equation, I'm going to say y, or f of x, is equal to, this is a square root function, and I'm stretching it by a factor of 3, so it's 3 square root. I've moved left 3, so I'm going to say 3 times x plus 3. I'm moving it down 3, so then that's -3. Okay, just to reinforce this idea of this stretch, I went over 1, up 3 on this. Notice what happened when I had a 1 there. I went over 1, up 1, and that's what told me that this a value was 1 here. Here it was 3. Alright, this one, obviously a cube root, so I'm going to say x is all real numbers, y is all real numbers. Okay, there are no restrictions there. When I think about this, I'm doing y is equal to a times the cube root of x minus h plus k. So let's fill in the easy stuff first. So I'm going to say f of x is equal to, I'm going to leave the a value blank for a minute, the cube root of, I'm moving right 1, so this is x minus 1, and I'm going up 2, so plus 2. Now we have to be careful here. What is this a value? Typically, like we said, we're going over and up. Here I'm going right 1 and down 1. So my a value is 1, but it's negative because it's been flipped. So notice how this looks different than the one before. This one I was going right 1 and up 1 because I had a 1, a positive 1 as my a value. Whereas on this one I was going right 1 and down 1, so I said negative 1. Alright, so that's graphing. Next things we got into talking about was our operations on power functions. These ones were pretty basic. This is just adding and subtracting. So if I'm asking you to take f minus g, that's 2x to the 1/4, minus 5x to the 1/4. Notice that the stuff, and we called it the junk, after my numbers is the same, so these are like terms, and all I have to do is take 2 minus 5 is negative 3x to the 1/4. Okay? Negative 3x to the 1/4. Coming over here, now I've got f over g, so I'm saying that's x to the negative 1/5, all divided by x to the 3/5. If I do this one, I have the same base, so I can work with my exponents. I've already got a common denominator, so I can work with that right off the bat. So I'm going to take negative 1 minus 3/5. So negative 1/5 minus 3/5 is going to give me x to the negative 4/5, which is going to give me 1 over x to the 4/5. Now, we have to be careful here, because if this was in radical notation, this would be 1 over the 5th root of x to the 4th. We never want a radical on the bottom. I only have a 1 on top, so I can't do any simplifying. So this is where we talk about having to rationalize. So I'm trying to figure out what would be a good value to have underneath so that I could easily take the 5th root. Well, if I multiply by 5th root of x over the 5th root of x, what that gives me on top is 1 times the 5th root of x is 5th root of x over the 5th root of x to the 4th times x is going to give me 5th root of x to the 5th. That's good, because then I can rewrite this. Top doesn't change, but on the bottom I can just call this x, and I've gotten rid of that radical in my denominator. Okay, so that's rationalizing. Verifying that f and g are inverses. If you remember what we had to do here, we had to say that f of g of x equals x, and the other way, g of f of x equals x. Now, I will tell you right now, you aren't going to see a verify problem on the test. However, doing these compositions, you definitely will see. Okay, so it's that piece of the problem that we're really practicing here. So, let's do f of g of x, which means I'm taking x to the 1/3 over 2 and plugging it in right there. So I'm going to say f of g of x is 8. The x gets replaced by x to the 1/3 over 2, and all of that is to the 3rd power. So this is going to give me 8 times. I can distribute my 3 to both of these, so 3 times 1/3 is x, and let's put a parenthesis around it, over 2 cubed is 8. That gives me 8x over 8, and I come up with an x. We're not going to circle that, we're just going to say, yep, that checks out in that direction. Going the other way now, if I'm going to do g of f of x, that means I'm taking f and plugging it in to g. So I've got 8x cubed replaces x, and all of that is being raised to the 1/3 power, all over 2. So distribute my 1/3. Since these two are multiplied, I can do that. This would not be a valid move. If I had this to the 1/3 power, you cannot distribute because they're adding. Okay, so just be careful of that. So when I take 8 to the 1/3, that's like cube rooting 8. That gives me 2. 3 times 1/3 is going to give me x. So I've got 2x over 2, which equals x. Just off the top of my head, maybe we should try one more of these. We won't verify, but let's say that f of x equals, I don't know, the square root of x plus 8, and g of x is equal to x squared minus 7. If we found f of g of x, that would give me plugging this into f, and that's going to give me the square root of, I replace x with x squared minus 7 plus 8. That would give me, combining like terms, x squared negative 7 plus 8 is plus 1, and this is where you have to be careful. I cannot simplify this. What I'm going to see a lot of you guys do is call this x plus 1, because you're going to square root this and this. You cannot do that. Because they are being added, this is as far as I can go. Okay, it's the square root of x squared plus 1. Okay, so that's composition. That was the new stuff that we learned there. Back to section 7.2, this is more just simplifying stuff. And we're looking at radicals here. So I'm taking the cube root of this entire expression. So I'm going to just cube root each piece individually and see what I come up with. So the cube root of 27, 3. Cube root of x cubed, x. Cube root of y to the 6th is y squared. Cube root of z to the 9th is going to give me z cubed. Everything worked out perfect there. There is nothing left underneath my radical, so that would be my final answer. If I'm doing the 4th root of 256 xy to the 8th, again, do each piece. So if I take the 4th root of 256, if you don't know that one, that's 16 times 16, which is 4 and 4. And 4 and 4. I'm looking for groups of 4. I have that with nothing left, so I can bring 1 4 on the outside. Okay, so that takes care of my 256. Now I'm going to take the 4th root of x. I need groups of 4. I only have 1, so that has to stay in there. It's going to be the 4th root of x. I can't do anything with that. If I take the 4th root of y to the 8th, that's going to come back out as y squared, because I can bring 2 groups of 4 out. So 4y squared, 4th root of x, would be this one in simplest form. Okay, this one, I've got the square root of 12x squared over the square root of 3. What you might be tempted to do here is think, oh, well, I've got a radical, so I have to rationalize right away. Be careful, and I'm not saying that's wrong, it's just going to lead to more simplification. Since I have the square root and the square root, we're in good shape, because if I have square root of 2 times square root of 5, we all know that that would give me square root of 10. Since this was the same I just multiplied, same idea holds true here. I can divide these to just say that this is equal to the square root of 4x squared. Square root 4 is 2, square root of x squared is x. On the test, do not put absolute values in there, because I'm really not worried about that. On this one, like I said, for those of you who are trying to impress me, this would need absolute value, because if I take my even odd rule, it was an even index, even power, it came back odd, so technically it would need absolute value. As I said, do not worry about that. Okay? Moving on, here I've got the 6th root of 9xy to the 6th times the 6th root of 6 times x to the 12th. First thing I notice here is I've got the 6's are the same, so let's just combine this into one radical right off the bat. So 9 times 6, 54. X times x to the 12th, x to the 13th. Y to the 6th times nothing is y to the 6th. Alright, so now let's go through this. If I do the 6th root of 54, I'm looking for groups of 6. This is 9 times 6, this is 3 and 3, 2 and 3. I have no groups of 6. So that has to stay underneath the radical. I cannot simplify that anymore. Excuse me. Okay? If I get to my x to the 13th, again, I'm looking for groups of 6. I could pull 2 of those out, leaving me with just 1x left on the inside. If I look at the 6th root of y to the 6th, I could say, well, 6th root of y to the 6th, I need a group of 6, so I can bring 1y out. Again, technically, this one needs absolute value around the y. Do not worry about that. Okay, so just ignore your absolute values if you are not 100% confident with those. This next one, I've got 3xy to the negative 1 over 12x to the 1/2 y. So I'm just going to go piece by piece. Put a fraction bar, 3 divided by 12. That gives me 4 on the bottom, 1 over 4. I've got x to the first and x to the 1/2. So if I thought of this as 2 over 2, my exponent property tells me to subtract. So 2 over 2 minus 1 over 2 is going to give me 1 over 2. So on the top, I'm going to have x to the 1/2. And I've got y to the negative 1 and y to the positive 1 here. So two ways of looking at this. You can either subtract these or just know that y to the negative 1 gets moved to the bottom as y to the first. So really I have two y's down there and it would be y squared. Okay, moving on. Adding these, again talking about that same junk at the end, you need to have like terms in order to combine them. I have that. Cube root of 3, cube root of 3. There's a 1 out front here. This one's easy. 3 cube root of 3. Next one, not as easy, because I've got the square root of 18 plus square root of 200. These are not like terms, so what that requires me to do then is to break these down. So I'm going to, let's change this one up just a little bit. Let's say this was 2 square root of 18 plus 200. So this 2 is out front already, so I'm going to break down 18 as 9 and 2. 3 and 3. I'm looking for groups of 2, so I could bring a 3 out. So this is going to be 2 times 3. Square root of 2 remains on the inside. Okay, that was the buddy who, or that's the guy who didn't have a buddy to get out. If I do 200, 200 I could do as 10 and 20. You could do 5 and 2, 5 and 4, 2 and 2. So I've got a group of 2 there. If I look at these 5s here, I've got a group of those, so I could make this plus, I bring a 5 out and a 2, so that's 5 times 2 is 10. Square root of the only thing that's left, let's change the color here, is this little guy hiding right there. So it's 10 square root of 2. So this right here, 2 times 3 is 6 square root of 2, plus 10 square root of 2. It's going to give me 16 square root of 2. Okay, so if you pause the video there, just make note, I changed it up a little bit. I put a 2 in there so that this was 2 times 3. We're rolling along here. Next one, more exponent properties. So this one says cube root of 4 times the cube root of 2. Both of these have the same index, so I can call this the cube root of 4 times 2 is 8. This is 2. Here I've got same base, so let's work with my exponents, which requires me to get a common denominator. Common denominator would be over 12. So 3 times 4, so this is going to give me 5 to the 8 over 12. Times 5 to the 4 times 3. So 3 times 1 is 3 over 12. That's going to give me 5 to the 11 over 12. If it asks for it in exponent form, there you are. If it asks for it in exponent form, or excuse me, not exponent form, radical form, this would be your answer. So just be careful on the test what the directions are telling you to look for. Alrighty, we'll keep going here. I see on this one I've got cube root of 3 over the 5th root of 3. I have the same base, which means work with my exponents. Now, that's going to require us to rewrite this as 3 to the 1/3 over 3 to the 1/5. Since I have same base and I'm working with my exponents, my property tells me to subtract. And in doing so, I need a common denominator. So I'm going to do this over 15. So that's going to be 5 over 15. This is going to be 3 over 15. So my answer, since I had the same base, that stays in my answer, 3 to the 2 over 15. Last one, if we look at this, I'm taking a look and I see I don't have the same base, I don't have the same exponent. So if you remember from our notes, we said, well, what if that happens? What if I don't have same base or same exponent? We say that you have to force it to be the same base. So we're going to rewrite this so that they do have the same base. So for starters, I'm going to write this as 3. We'll go to the 1/3 times 9. It can be rewritten as 3 squared, all to the 1/5. If I simplify here, I've got 3 to the 1/3 times 3 to the 2/5. And now we're in good shape. I've got same bases, so let's work with my exponents. In order to do so, I need to add them and get a common denominator. So this is going to be 5 over 15. This is going to be 6 over 15, leaving me with 3 to the 5 plus 6 is 11 over 15. So that one was a little trickier. Didn't have same base or same exponent, so we had to rewrite. Next one, this one is just rationalizing. Excuse me, I don't have anything to simplify right off the bat. So what I'm going to do is I'm going to take the 4th root at the top over the 4th root at the bottom. On the top, this will simplify to, I can bring one x out, and there is 1 left trapped underneath. So x times the 4th root of x over 4th root of 27. That is not a perfect 4th power, so I can't do anything there. This is where I said, okay, we got to get rid of that bottom. So I got to figure out, what do I want to multiply by underneath the 4th root so that this comes out nice. And if we look here and think 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is 256, and you could keep going. So I'm looking, which one of these numbers right here could I turn 27 into? And the answer is I could turn that into an 81 if I multiplied by a 3 and a 3. Multiplying then gives me x times the 4th root of, this will be 3x, over the 4th root of 27 times 3 is 81, which is a good thing because I want to get rid of that radical. So the top, nothing I can do there. I divide then the 4th root of 81. This is what we wanted. The 4th root of 81 is 3. So we are then done. Alright, so back or on to the last section where we were solving, and this was where we really had to check for extraneous solutions at times. Remember, that is only needed when we are squaring or taking something to the 4th power or 6th power, any even power. Again, if you can't commit that to memory, it's always a good idea just to check all of your answers. So on this one, I have an x trapped underneath my square root, so I'm going to square both sides. Okay, if I square this, left hand side is just 4x. Right hand side, take the minute to do that if you need to. This is going to be x squared minus 16x, and maybe I should write that out. This is x minus 8 times x minus 8, so this is going to be plus 64. It's a quadratic, so we need to get it set equal to 0, so I'm going to say x squared subtract 4x is going to give me minus 20x plus 64. This one does factor. I get x and x. Factors of 64 would be 16 and 4. I need to get to negative 20, so they're both minus, and that tells me that x equals 4, x equals 16. Now, since I squared both sides right away, I need to go back and check these. So if I plug a 4 in, that's going to give me for my check, 4 times 4 is 16. Square root of 16 is 4. If I plug that same 4 in here, I get 4 minus 8 is negative 4. That is a false statement. 4 is what we call an extraneous solution, so we have to cross it out. Alright, if I plug the 16 in, that's going to give me the square root of 64, which is 8. If I plug the 16 in on the right side, 16 minus 8 is 8. That one's a good solution. That's a true statement. So x equals 16 is my answer. Alright, this one, I want to get the x all by itself. So let's say that x to the 5 halves is equal to add 10 and I get 32. So I need to get rid of the 5 over 2. So what I'm going to do is I'm going to take both sides to the 2/5 power. Because in doing so, I've got power of a power means multiply. 5 over 2 times 2 over 5. Those are gone. And I've got x is equal to 32 to the 2/5 is the 5th root of 32 squared. So I'm going to get x is equal to 5th root of 32 is 2. So 2 squared. This gives me x equals 4. That one I don't need to worry about because this was this rational exponent. Okay, so that one we're good to go there. For the sake of time, we won't check it. This one on the left here, I've got two square root expressions, both with x trapped underneath them. What we need to do on here is rewrite this as 4x plus 15. I'm going to add this whole term over to the other side because in doing so, I can now just square both sides, and in doing that, both of my radicals will disappear. So I square over here, and I'll show that step. Square it, that's going to give me 4x plus 15 is equal to, on the right hand side, if I go and square this entire thing, I got to distribute, so 3 squared is 9. Square root of x is, square root of x squared is x. Now it's just a basic equation to solve. So I've got 15 is equal to 5x. X is equal to 3. Okay, if we were to plug that back in, plugging the 3 in would give you square root of 27 minus 3 root 3 equals 0. Because I squared, I do need to check it. This does check out. Square root of 27, if I break that down, really is 3 root 3. So 3 root 3 minus 3 root 3 is 0. Therefore, this is a good solution. Okay, again, we're going through this kind of fast just because there's a lot of problems. So please pause it, rewind, slow down, whatever you need to do. I think, is this the last one? Yep. And then we'll call her quits. So this one, I've got the cube root of something plus 11 equals 14. So let's isolate that. Let's call this 7x minus 9. This is equal to 14 minus 11. If I take 14 minus 11, that's going to give me 3. To undo this cube root, let's cube both sides. That's going to give me 7x minus 9 is equal to 3 cubed is 27. I add 9 over, gives me 7x is equal to, what, 36? It's going to give me x is equal to 36 over 7. This one we do not have to check because I was taking it to an odd power, whereas here I was taking it to an even power, so I don't need to go back and check. Reason I'm not doing it here is for the sake of time, and if you plug 36 over 7 in there, this doesn't work out as nicely. Okay? So, that is the Chapter 7 review. Hopefully you have found this helpful, and we will call her quits there. You guys have a great rest of your morning, day, evening, night, whatever it may be. Later.